and it is a lovely day here to get this ball rolling. I think everything is going to go smoothly today. Welcome to JEHC. This is another episode, Volume 3, on independent front suspension design, IFS stuff, for desert, trucks, etc. I'm going to try and get through 4 pages of the outline today. We're going to cover bump steer, toe curve, a lot of facets in that with both steering racks, steering boxes. And then we're going to jump on some shock and bump layout stuff and possibly finish with vertical versus horizontal bearing setups and arms. So I might try and go a little bit faster today because I'm trying to make this not like 400 fucking volumes. At the same time, there's just a lot of stuff to cover. So it's hard to do that. But more importantly, my name is Jason Elvis Hurd. If you have watched these episodes or the previous stuff or any of the other horrible podcasts that I have put together, then you already know, for the most part, that I am co-founder in Tekk Consulting. So this is my firm, and we do stuff for different clients, things like that. You can call us, contact us. We do chassis design developments for race teams, privateers, manufacturers, etc., etc. We are very busy, so be patient. I also own DIY Off-Road, digital asset marketplace for the off-road industry. And this podcast, just like all the other BS, is 100% self-funded. So this is all done with our own stuff, so to speak, ourselves. We don't have sponsors. I don't have anyone to promote other than the bullshit that I deal with. Thankfully, I've been doing pretty well with what we're doing so far. I was able to build this studio, which I feel like is far more professional than my talent. But, everyone has a dream, right? And so with that said, I have to, at a minimum, push some of our stuff so I can justify the cost of this deal to my wife. And for those who have done business with Tekk and us, etc., you will know Natalie, my wife. She runs all the accounting and does all the books, does all the processing for DIY Off-Road. And so for obvious reasons, if I don't appropriately justify expenditures, I will get chewed the fuck out. And I also like getting laid. So for those 2 reasons, we are going to be promoting DIY flapper discs today. That's right. These bad boys are basically what I wanted when I was doing fab work. They are an angled flapper disc. They are a 60 grit, and they are beefy. I wouldn't say these are the highest quality flapper discs in the industry, but at the same time, for the cost, they are really good value. So they're definitely not the shittiest. They're definitely not the best. But you're going to be hard-pressed to find something that's as good a value for what we charge. And I don't make, like, millions of dollars off these or anything. I just thought it was something really cool to do for DIY Off-Road. And you can definitely check them out on the site. And they are $46 shipped. So, you can pick some of those up, and we'll ship them out. And I think I just broke my fucking mouse for the other computer. We'll see here. If that just happened, that is horrible timing. I am really screwing up this whole sponsored product thing. There we go. Better. Save the day. But yeah, so again, our sponsor, DIY Off-Road Abrasives for this episode. So they're sold in packs of 10, $46, and we can ship them to you in these packs of 10. And you can shred appropriately from there. So if you guys have questions on this stuff or any of the other DIY stuff, like we got other fabrication hard parts, 4130 sway bar ends. These things are pretty fucking rad for making sway bars. We have built link tabs. Ooh, I'm running low on these too. Natalie just informed me we are down to our last 4-inch one on the shelf. We're running low on 3.5s. I still have 3 1/4s, but these are built link tabs, all 4130. All that good stuff. So I feel like I have met my contractual obligation for this evening's episode. The wife's going to be happy. Our sponsors are going to be happy, and we can start moving forward with our bump steer and toe stuff relative to our discussions on independent front suspension design in the off-road industry. And there's a lot of debate in this stuff. What I'm going to review, I guess it's fair to say it is heavily opinionated with like stuff that I have dealt with, stuff that I prefer, but at the same time, like just like a lot of the other stuff I've been reviewing, there are spectrums that you kind of stay in or stuff that you stay around. And then there's variations in that spectrum where guys can win that are still on those variations or sides of the table and things like that. So it doesn't necessarily mean what I say is the end-all be-all. It doesn't necessarily mean that what someone else does, if it's not what I say, is incorrect, and vice versa. It simply means there's different strokes for different folks. I am just reviewing and giving you guys the information to understand this stuff so that you're better educated and you know a little bit more, or at least hopefully you know enough when you are building these vehicles or having a vehicle built or speaking with a builder, speaking with someone. You've got to, you know enough to be dangerous, so to speak. And that's not necessarily a bad thing, especially with the progression of this sport, how much discretionary income it costs to legitimately compete in this sport. You should be educated, and it's a passion too. So the guys who are a little bit more passionate obviously are going to be a little bit more obsessed to some degree, like myself. And we enjoy this, doing these episodes, doing this stuff, knowing this information doesn't necessarily make you wealthy or will ever make me wealthy by any measure. But it is a passion and an obsession. So with that said, let's jump right in. So first and foremost, zero bump steer is a fucking myth. It doesn't exist. If you've got a guy that is touting the zero bump steer myth, it's kind of like a red flag that they don't know what they're talking about. And maybe, because I've seen some of the guys that I definitely do know that I know that they know what they're talking about. They use this zero bump steer connotation to something that basically references like a toe change so low that it's going to be difficult to spot with the human eye at the front edge of the tire. And so what I mean is that if you're putting this stuff in the computer, you're maneuvering it, etc., you're not going to run across a scenario of zero bump steer. And if you do, i.e. numerically speaking, in the computer, there's a high probability you have other stuff pretty drastically wrong. And you're going to want to go back to the drawing board and review some of those other facets, camber caster curves, things along those lines, placement of your items, inclination. Because if you've got that stuff in the correct ballparks, you're never, ever going to have zero bump steer. This is also good to note for those who are designing or just starting out on this stuff, to not sit there and pull your fucking hair out all day long, because you're under this sort of like bullshit impression that these other individuals are creating zero bump steer, and that's the metric you need to uphold. And if you're down to a fucking 16th or a 32nd or a fucking quarter inch, oh my God, these guys are just going to chastise you. Well, I hate to break it to you, but some of the best engineered trucks have a little bit more than that, so to speak. And, the bottom line is the dirt is very forgiving. Now, in a road car, road race applications, if you've got a quarter inch of toe change through 2 inches of travel, you're fucked. If you have a quarter inch of toe change and 24 inches of travel, the probability that the driver can feel that, I'm going with slim to fucking none. Maybe like a Robbie Gordon or a McAckran or someone that is very versed. I might even say Kyle Jurgensen in that measure. He has done great. Harvey Lentner. I can keep going. There's a ton of guys. There's at least 24 individuals, racers, that legitimately can probably articulate the feeling that they have from truck to truck, whereas the vast majority, unfortunately, are not enough, do not have enough experience or understanding of the engineering basics to be able to articulate appropriately. But with that said, my point being is there's a huge misconception with the zero bump steer myth. And more importantly, you don't want zero bump steer. So even if I was able to achieve that, that would be a bad thing, not a good thing. Again, it's just one of those terms that gets thrown around and people start accumulating that as some sort of marketing posture that they have to uphold in a fashion that makes it so that if you're not in the zero bump steer club, you're fucked. And so that needs to be understood that is not the case. In fact, it's kind of the opposite. And the way I like to think about it and the way I explain it to people is zero bump steer, again, it's a fucking myth. It's a joke. Let's just get that out of the way. What you want to focus on and what you want to refer to would be toe curve. And what you want is a controlled and steady toe curve. You want something that's predictable, and you want something that you can have very little, wiggly in. You want it to be nice and smooth through travel. And when I say through travel, what I mean is if you were to predict extension full extension all the way up to compression. You want a nice, smooth curve, as smooth as you can get it. Now, again, you're never going to get that curve perfectly smooth. That is also a mathematical impossibility. And there's also debate, too, because you have to figure out both in-turn bump steer and basically straight-on bump steer. Most people are just looking at the truck straight on, and they're just calling that, the bump steer from there. But you have to keep in mind the vast majority of the time that it is considered important, per se. The truck will not be going straight. Now, in the big, heavy, rough stuff, for the most part, you will be going straight. But when you're getting through some rough stuff and turning and things like that, and the in-turn bump steer presents itself, and you have really bad bump steer, that's when you really start to feel it a lot more. As well as, you do feel it in the rough stuff too. But my point being is that it's not as simple as just saying, when I look at the truck head on, is there bump steer? And now you're getting into a little bit of the discrepancies between racks and steering boxes. And I'm going to go through all of that. But let's focus on the measurement of toe curve, so to speak. You want to take the leading edge of the tire. That's where you want to measure from. So if I'm designing a setup that's for 40-inch tires, I'm obviously going to pull the leading edge of a 40-inch tire in my design. And you want to make sure that leading edge is pulled from the front. And you have to be careful when you're running setups that have either rake in them or inconsistent caster, because that leading edge technically rotates on the tire. So it's not as simple as just picking a static point on the upright, because then, it'll move, so to speak. And so you always want to focus on the leading edge of the tire, i.e. the furthermost forward point of the tire, and basically pick that in the computer, and you're going to use that. So for a 37, you use that. For a 40, you use that. 42, you use that. So for obvious reasons, the 42 is going to have little bit more accurate, so to speak, of a measurement, because you're further away from center line of the upright, which means that little bit of measurement right there, dialing that down to a 16th or whatever number you pick, is obviously a little bit more accurate than dialing a 37 down. Because the 37 at a 16th, when you extrapolate that out to a 42, you could end up being double that or triple. That arc, that measurement, so to speak, because you're further away from the center point of the upright, will change. So you always want to use the largest tire size per se that you are designing that specific suspension for. If you're on the fence between 37 and 39, go with the 39, is what I'm getting at here. Because the larger the tire, the further out that point is, the more accurate your numbers and measurements are going to end up when it comes to deploying that in the physical world. So yeah, and then again, with the inconsistent caster setups where that caster is, changing and caster gaining, through travel or anti-diving, however you want to call it, as it's gaining through travel or it's losing caster on the extension side, you have to remember, if that leading edge of the tire, if you pick it in the computer as a static, it's going to either rotate up or it's going to rotate forward. So what I like to do is I just pick a point and then I just hold to the center of the upright in the computer, and then I have this sort of structure that basically just sits level to the ground no matter what the caster changes to, and it will hold the leading edge of the tire. And that's like the good way to measure in the computer. And I'm going to show some diagrams on how we do it here at Tekk. I'm also going to go through some of like the old school ways of doing it as well, so you can kind of get some understanding in that. But before we dive into that, let's go through one of the questions I get most often is cost. And I think one of the biggest misconceptions is that by going with a steering box and swingers, it's cheaper. That is rarely the case when we're referring these types of vehicles. Rarely the case. Typically, a steering box and swingers is going to be more expensive by double, maybe triple, depending on what your comparison is. You'd be surprised how economical, relatively speaking, a solid rack setup is. Like PSS, now to be fair, Pro-Am is a little bit more on the expensive side. Pro-Am does make really high quality racks, to be fair. So it's just like everything. There are, and I'm going to go through the differences, but the point being is, it's not a fair assumption that a steering rack is inherently going to be more expensive than a steering box setup. And I definitely argue that steering box swingers, properly done, mind you, is going to end up being more expensive, said and done, than a rack-based setup. So you need to keep that in mind too when you are starting to factor this stuff into the equation. Now there also could be examples that I'm well aware of where a steering box setup could be cheaper than a steering rack. So if you take one of the more expensive racks and you take like the cheapest, most simple steering box type setup you could design and build around, well, yes, then that might inverse what I'm saying. But again, you're starting to split hairs because you're taking variance in between those two facets. But generally speaking, the steering box applications will be more expensive for the end user. And so keep that in mind and don't just assume that in general it's the inverse. I see a lot of that online, and a lot of people, giving other individuals recommendations that yeah, oh, it's cheap, so we're going to do that. And that's unfortunately just not necessarily, and it's certainly not the fucking case now with trophy truck shit. Definitely not. A rack is way cheaper, properly done. So let's go into what I refer to for the curve, or the toe curve, so to speak. So the toe curve is how I like to define what would be your bump steer or bump steer control or mitigation, mind you, or no bump steer, guys. Because I don't want zero bump steer. I want that to have a controlled curve. And again, this is my preference with a lot of these types of trucks. I like to have toe increase at compression, and I like to have it slightly decrease at extension. So in other words, if you were to have fully extension, and let's say the tire is basically straight, we're going to have it towards ride height. It's going to toe in a little bit. And again, there's discrepancies in where guys like to set those. 16th per side, 1/8 inch per side, quarter per side. That's really fucking high. But the point being is there's going to be some discrepancy on how guys like to set the ride height one. And then I like to have that kind of just, go from extension to basically 0 to your ride height number, and then just kind of keep curving and just gently sort of increase that compression to have a little bit of toe change inward at compression. Now that is a generalization on how I like to do things for a lot of trucks. To be perfectly fair, I do know some guys that are doing toe out at ride height, like some sandcar-esque stuff and sand truck-esque stuff. So there is some variation in that. So it's not a generalization that you're towing in like I am saying in everything. And now when I'm referring to this, it's just looking at it in a straight line. So we're just going to start with that for now. We'll get into the more complex through turn stuff once I dive more into swingers. And these are kind of like generalized toe curve measurements or toe curve ideas. So let's say, for example, we have one driver that prefers it to be a 16th per side towed in at ride height. So we'll go an 1/8 inch, at ride height towed in. And then what we will do is design it to where that toe curve will just gently come up and probably gain like another 1/8 inch towards the top side. We have had guys, to be fair, have that compression side of toe curve go all the way up to 3/4 of gain. And when I say gain, I mean toe in. So it's towing in more at compression. And that was a preference by that specific driver. So again, there's variance in this and preference in this. But the point being is you just need to understand that what you're really looking for is to have that curve as smooth as possible. You want to get all the cattywampusness out of it. You don't want it to be jagged. You don't want to be shooting back and forth while you're going through this travel, so to speak. So the key here is smooth, fluid control. And you want it to be predictable, i.e. I want it to, at ride height, when I know I set it at a 16th or an 1/8 or whatever the fuck your flavor is at ride height, you want to be able just to have that nice smooth curve all the way up through into your full compression. And that is realistically the goal with your toe curve, not zero bump steer. If you truly did have zero bump steer, it's going to be less stable at compression, and it's going to cause a little bit of other weirdness. So for a good generalization, what you're basically going to try and find is the sweet spot that you or the driver or client prefers when it comes to both ride height and compression toe. And you want to build your curve appropriate to that. Now, there's obviously some debate and a lot of differences in that, et cetera, et cetera. And like I'm saying, I've set trucks up and front ends up in various fashions. But no matter what those specific numbers are going to be for said client or builder, I'm still always focused on mitigating the roughness in that curve. That's also key. Yeah, but now if you've got like fucking an inch, 2 inches, fucking stuff like that, like you're fucked. You know, like the Polaris is a real world example. That's more recent, and you'll see it too. Like if you'll see some of the trophy truck builders and stuff like that. I mean, and I can show some pictures too. Like it's not perfect by any means. And there's intentional, on the compression side, it's definitely intentionally done. But it's so, even with that said, like a 1/4 inch is very, on a 40-inch tire, is very difficult to see with the human eye. Very difficult. You know, even up to like a 3/4 of an inch. And just so we're clear, when I am referring to toe, that is a measurement of the leading edge of the front tire relative to the rear or trailing edge of that front tire in space. So if it's an 1/8 inch, that means that measurement up front is an 1/8 inch narrower than the rear. Now, depending on who you talk to, who's designing, etc., they could be referring to it as a one side only. So if they're referring to 1/8 inch over, it might be just 1/16 in design, because you design from one side of the chassis, so to speak. Like in a center mount setup, or like the stuff I've showed you previously, the stuff that almost everything we design other than like fucking beam trucks and shit like that, you're basically designing a symmetrical chassis. So you're designing one side of the vehicle, i.e. I'm designing the driver's side. So I'm designing the driver's side upper arm, upright, and lower arm. So if I'm referring to the toe change, I could be calling out a number like a 1/16th. And that would be for that one side, which now obviously you double, because you have to double to the other side, and that would be an 1/8. And up and down from there. 32nd, 16th, 5/16, 1/4, however you want to denote the number. You just have to keep in mind those are two different ways of looking at it. You could look at the overall, or you could look at just one side. But the key here is it's a variation of the leading edge of the tire relative to the trailing edge of the tire. And it's the front tire. And that is going to be turned to where that front will be a different number than the rear. And that's where we're getting the delineation of what I'm referring to. And when it's in, so to speak, that means the front is narrower than the rear. So the leading edge has a smaller number than the trailing edge of the tire. When it's out, that's an inverse of that. The leading edge of the tire will have a larger number than the trailing edge of the tire. So just to get some basics out of the way. So there's some of that. And if you disagree with me, you can appropriately admonish me in the comments. I probably won't read them. I mean, I might. We'll see. Let's see here. Let's go to, what are all my notes? Initial setup. Okay, cool. Go into this. Click this bad boy over. Bump steer. Kind of made a little diagram of this. I think that's a good starting point. Let's start with this one. So, as you can see here, we have I have made a gorgeous diagram with that has disappeared. With Microsoft Paint. There we go. And hopefully you guys can see what's going on here. But motherfucking tire, lower arm, upper arm, chassis, and this would simulate the upright. So this is like you're looking at the truck head on, and this would simulate the driver's side. So if I'm like, it's the truck's facing me, and I'm staring down it, so to speak. And these little dots here would represent kind of like where to start with this. So let's say I've got my camber caster curve all fucking rad, my inclination all rad, etc. On the interior side here, we're just going to draw an imaginary line. That sort of would be the upper pivot in the chassis to the lower pivot in the chassis. And that would sort of be like the inverse side or the chassis side of where the inclination is. Now, you would just, to get this ball rolling, and this is a super generalization, so you would pick a point on both sides that's roughly the same percentage up each side, because remember, your upright spread should be greater than the chassis spread. And so you're going to pick a point, and then pick that same point percentage-wise on the other side, on inclination, and then on that line. So we're looking at the red dots here, which is that right there. So that would simulate our steering linkage, steering arm, tie rod arm, whatever you want to call it. The fucking thing with rod ends in it that holds the upright to the steering mechanism, whether it's a rack or swinger system. So right here is it basically on the inclination and that imaginary line. And that is theoretically like the best spot to start, if you're kind of doing this by hand per se, to quackulate your bump steer or toe curve mitigation. Yeah, let's use that one. In an appropriate manner relative to your geometry. And we're just going to focus on staring at it head on right now. So that's like a good generalized starting point or initial setup. And we're going to get more complex than this, so let's dive in. Let's dive into Ackerman. I have mentioned this before on here, and it's one of those things I think maybe misunderstood by some, not fully understood, or like there's a lot of talk about Ackerman in the relationship to like, oh, you have to have, like there's some very opinionated metrics on Ackerman. And there's also a lot of debate in off-road as to whether the fuck it even matters to some degree. And I'll tell you my thoughts on it here in a moment, but let's review what Ackerman is. I found this diagram online. I don't know where the fuck it came from. I thought it had a stamp on it so I could give them credit, but it doesn't. So let's just say that I made this, you know, fucking plagiarizing. But we're going to call this, well, in off-road, I like to think of this in a manner a little different than road racing, etc., because it's not fair to apply the same sort of quackulations and predictions with Ackerman that would be in a road car relative to off-road. I don't think that's a fair comparison for two reasons. One, we have like 10 times the fucking travel of like a road race car. So right out of the gate, as soon as you start moving this shit around, everything gets fucked up. I mean, all the shit, it's just fucked up. So there's a reason why it's hard to have predictable sort of quackulations as you would in like a road race car per se. And number two, these vehicles don't really have traction per se. They have some traction, but it's really fucking bad. It's like the equivalent. No, not a drift car would have more traction for sure. And they're like intentionally breaking loose. So in off-road, you're sliding, and you're sliding all fucking fucked up cattywampus ways. So the predictability of any of that, again, is very difficult. And realistically with off-road, or at least from my observations, experience, and the simple fact that I have been doing this for 20 years, really revolves around talking with drivers, talking with other engineers, talking with guys that do design work like myself, talking with builders, and just listening to what they say, listening to their thoughts on this stuff, and going from there as opposed to like, oh, I like specific calculations or things like that. And here's where I'm going with this, because it's a good way to sort of get it into three generalizations when it comes to off-road. On the far left here, we have Ackerman. So we're just going to call Ackerman straight up. Anytime that the interior tire turns faster than the exterior tire, that is what we're going to call Ackerman. And the way I like to measure that is in degrees, i.e. my interior tire turns, and I refer to at lock, just so we're clear. So if you have a system and like a steering rack that has a throw of 6 inches, 3 inches is lock on my driver's side. So I like to measure Ackerman for off-road trucks relative to full lock on one side. So that, let's just go driver's side because that's usually what I design to. So full lock and the variance of full lock to one side from the interior to the exterior tire. So when I refer to Ackerman at 2 degrees, when I refer to Ackerman at 4 degrees, that is what I'm referring to. It's the interior tire being 2 degrees sharper than the exterior tire, or the interior tire being 4 degrees sharper than the exterior tire at full lock. Whether it's swing set steering or a steering rack, we use that full lock as my measurement, and that's what I am referring to when I say specific degrees for Ackerman relating to off-road trucks in this fashion. And I want to keep it that simple. I do not want to get it any more complex, because with road racing and things like that, for obvious reasons, we can start to dive into far more fuckery in the mathematics department. I don't think that applies to off-road, or it just doesn't apply generally, because it seems like when you're dealing with, customers or clients that do understand Ackerman, etc., the best explanation and the best way to set it. Oh, again, and I'm measuring this at ride height, to be perfectly fair. I forgot to measure that. So, is to discuss this in a fashion of, if the client does want Ackerman, they want it in a number of degrees, 2, 3, 4, 5 degrees, so to speak, at ride height, full lock. And that is how many more degrees does the interior tire turn than the exterior tire. I like to use that as a very simple metric to use that for a design premise or the design baseline when a client says, oh, I want Ackerman in the system, or, okay, so how much? That's what I'm referring to. At ride height, full lock, variance between interior tire and exterior tire. And so that's what we have here on the left. If you look closely, that would be what we call Ackerman. Fucking zooming in. Look at this. I am really getting this podcast shit down, bro. I don't even need a Jamie or a Jack. Well, maybe Jack. Jack definitely has to come back for like the Ultimaniac episode. But anyways, so that is perfect example. That one right there looks like a decent amount of degrees. Fucking like 8 or 10 degrees. And so that's what I'm referring to. So when I say an Ackerman of 2 degrees, that is the specific metric I'm using. So now that we got that out of the way, you understand moving forward what I'm getting at when I state specific degrees with Ackerman. It's ride height, full lock, interior tire degree relative to exterior tire degree. It's a good way of noting what it is in an off-road truck, because all the others are so fucking cattywampus anyways, and we'll get into that too. Now, let's go over what parallel is. I mean, it's exactly what it sounds like. The tires move in parallel. So the Ackerman at that would be 0 degrees by my definition, or the way I would talk about it with clients. So 0 degrees is that. Simple as fuck. Now let's talk about some real fucking awesome shit. Reverse Ackerman, or what I will refer to as negative, so to speak, i.e. I am having the outside tire now turn sharper than the interior tire. And there's definitely cases to be made for this. So there's a lot of debate and a lot of discussion in this stuff. There's a valid case for some reverse Ackerman in a rear steer type of chassis as well. And now you're going to start getting into far more advanced stuff than we're going to dive into tonight, primarily because I'm trying to focus on the front end. And on the rear end section, when I get, to the rear end stuff, we will dive into some of the rear steer based trucks and applications, because there are some, and some guys are very opinionated in that, as that they fucking hate it. And some guys definitely like it. So again, different strokes for different folks, but what we can get from this completely stolen diagram is that when I am referring to Ackerman in a specific degree, i.e. if the degree is positive, that means the interior tire is turning faster than the exterior. If it's 0 degrees, I am referring to parallel. And if it's negative, I am referring to reverse Ackerman, which means the outside tire is now turning faster than the inside tire. So those are, again, just a very good way of looking at it, and in a good way that I have found about explaining to clients and dealing with clients in this situation. And most of the guys we deal with, they're not even asking these questions per se. We've definitely had some, and it's more that more experienced guys are usually either concerned with this or just want to know, or they have a recommendation, or they have a specific measure they want us to adhere to. And so, yeah, again, it's something cool, and we'll dive into some more. So that right there is the general concept with turning variance and Ackerman. So now let's talk about building Ackerman into the system. And there's 2 ways to do this that can kind of work in symmetry, or they can fight each other. And I kind of touched on this in the Volume 1 episode, and I didn't touch on the other aspect of it. And what that is, so we've got, we're going back to this bad boy. Now, in this situation, we are using a point on the upright that is basically centered on inclination when you're looking dead onto the fucking truck and the motherfucking tire. Now, to build Ackerman into the system, we're going to be shifting that point outboard. And you'll see this with a lot of trucks, i.e. the rod end, so to speak, is out towards the caliper. There you go. See how buried that rod end is relative to inclination angle? He's almost touching the caliper. This is a SST truck. Good old Gordon. Really cool stuff too, by the way. See if I have another example. This is like the random ass example fucking lot. But you can just see he's pretty buried in that specific example. So, as I move that point on the this guy right here, as I move this point outboard of the inclination angle, looking head on the vehicle, we also have to mimic that on the interior side, or you're going to find that you're going to be forced to mimic that. Otherwise, you're going to start getting that cattywampus toe curve. That shit's going to be fucked. So, as I move further out, we're going to end up with more Ackerman. We're going to end up with steeper degrees of turning in that diagram I showed you. So that is one way for adding Ackerman into the system. Now, another way would be let me pull up start. Here we go. Would be this. The location of the steering rack and the pivot in the chassis relative to the upright. This is looking straight down in the chassis. The location for the chassis side of our steering pivot is further rearward in the chassis than the location on the upright. This naturally will cause the interior tire to turn faster as that rack moves side to side and goes into full lock than the exterior tire. This is one way of building Ackerman into the system. So you've got these two variables, so to speak, that allow you to build Ackerman into the system, this guy and this guy. So we start off with the red line. That's on center, so to speak, of our inclination and center of our chassis line. We move it outboard a little bit. That's our blue line here. So that's adding a little bit into the system. And then we go mega fuckery green. We shove it all the way to the caliper. I'm sorry, the rotor. Because typically speaking, the rod end and stuff like that has to have clearance on that rotor. That's what you're going to end up with most of the time is a clearance issue. Now, there is definitely a lot of debate in what is correct with these three metrics. So let's review some real quick. So here's a Mason. On this Mason, you can see that the center point of the steering is not far off of inclination angle. You know, it's hard to tell, but it's right about here. So they're clearly keeping it a little bit closer to inclination angle on that steering side. So that's just an observation. That's all we're paying attention to that. This is it's hard to tell in this. This is previously, before Robbie cut this truck up and made it into the Unicorn, you can see how far forward the steering rack is in this, and you can see the angle of the steering arm is actually the inverse of what I just showed you this CAD file of right here. Whoa, that is incorrect. Right here. So his rack is basically up in this area of the chassis. So we're just reviewing some differences, and then I'll go into what this stuff means here in a second. This one, again, it is very close to that outside. So it would be fair to assume he's got Ackerman in these SST trucks, a decent amount. So there's just some quick examples on what I'm referring to with the rack placement in the chassis and sort of this upright placement. So you understand these two ways of building Ackerman into the system. Now, let's review some of the stuff that I prefer, so to speak. So, for starters, I am not sold on high Ackerman. I do not like it. I think it creates a lot of problems. And what I consider high Ackerman is above 5 degrees positive variance. So in other words, if the inside tire is turning more than 5 degrees than the outside tire. This is a personal preference of mine. And that does not mean that if you don't do that, you're wrong, etc. I'm just going off of preference. A lot of the trucks I set up are between 2 and like 4 degrees of positive Ackerman. So they are turning 2 to 4 degrees sharper on the interior tire than the exterior tire. I feel like that is a very good mellow range for the majority of drivers. The reason I say that is because the application of reverse Ackerman or parallel to reverse Ackerman range, I feel like is something that works better in situations that are either more experienced drivers and trucks that intentionally deploy rear steer with the rear suspension, because my thoughts are reverse Ackerman is complemented by a rear steer chassis. I know I'm not alone in that thinking. There are some trucks set up in that fashion. I don't necessarily want to disclose whose, but if you're in the industry and you know, then you know what I'm referring to. And it is definitely more unique in both of those aspects. I think that most drivers do not prefer reverse Ackerman, and most drivers do not prefer rear steer. And the reason for that is preference, maybe experience, and driving style. For the reverse Ackerman to be complemented by rear steer, I feel like that is primarily going to be an application of a driver who drives a little bit more on the edge and a little bit more sideways than most, so to speak. And those would be like a complementary fashion where that would that could help a driver feel more comfortable per se. So hence why I'm saying the vast majority of stuff that I set up for, I mean, to put it nicely, like the drivers that aren't, the top tier of the sport, or the drivers who aren't experienced enough to specifically dictate that they want the reverse Ackerman, I set those vehicles up to be between 2 and 4. And the way I do that is far more closer to the blue line here. I prefer on the upright to be closer to the inclination angle, obviously outside of it, but I usually set stuff up to be a little bit on the closer side of the inclination angle than a lot of other applications that you see. And then what I do is I build Ackerman in with our steering rack location. So with what I do and how I like to do this, it does create some headaches and some complications. It also creates some positives. And again, there's different strokes for different folks. But let's review an inverse of what I am referring to. Right here. Like Robbie's situation, and I don't remember, it's been years since I've seen this truck, and he's cut this thing apart, so I don't know what the Unicorn is as far as relative to this. It is all-wheel drive now, so there's going to be their own issues involved with that. But his rack was very far forward in this truck, and now he did mitigate too much reverse Ackerman in that fashion, I believe, by having the upright point relatively further outboard of the inclination angle. So he was somewhat mitigating that in that fashion. Whereas what I'm doing is kind of the inverse of that. I am sticking, a little bit closer to inclination, a little bit more into like this blue line range. And then I am also going with moving the rack rearward to give me some of that Ackerman into the system. And the reason I like this is when you start to quackulate your toe curve, what we have found is, at least with the setups that I like, so in other words, your camber, your caster curves, the variations in your rake, inconsistent caster, and camber curves will be different than what I do. And so there's no like specific number I can tell you that's like, here's the least amount of toe curve fuckery. Like, this is where you're going to be. I can't tell you that. I have to map the suspension out because they're all so different, so to speak, that there's going to be a lot of variation. And so with that said, my point being is with mine and how I set a lot of vehicles up, I am a little closer to the inclination angle, and I find that that actually does create a less chattery toe curve. So a much smoother curve for our toe curve. Irrelevant, so to speak, of where we set that at compression and ride height. Because again, my goal is Those numbers obviously can change per client, i.e. what they set toe at ride height and compression. Like we can we can change that, but I never want to, go away from wanting that curve to be as smooth as possible. And so by being a little, closer to the inclination angle, we have found that curve is a little less fuckery. And so the further out you get, the more fuckery in that curve, unfortunately. So if you're being a stickler about that, then again, you would lean a little closer to the interior in that equation. Now, the other side of the argument is when you go to the outside of that, like this green line here, the fuckery at the toe curve on like a 40-inch tire, you may not be able to see that with the human eye. You see what I'm getting at? So the argument can be made that even though there's a lot of guys that put it in this fashion where they're shoving it very outboard towards the rotor, that doesn't mean it's wrong. I'm just giving you my preference, so to speak, and I've done stuff like this too. I've done quite a few like this too, and again, like I'm saying, these are just two kind of ways to get to the same sort of goal. And then, so with that, that's kind of like a good generalization as to where we're placing those two things to get us either to positive Ackerman or not. So if I was going to go parallel or reverse Ackerman, I will bring that steering rack a little bit more even in the chassis as well, and then even up some of the inclination stuff too, and bring that back to more of a parallel if, say, the client's like, I want 0 degrees change, so to speak. And then reverse, well, that's where you would move the rack or the chassis point forward. You don't really ever want to be interior of the inclination angle. If anything, you just want to be a hair on the exterior. So you can come up and hug it, but don't go inside of that. If you want to intentionally build reverse Ackerman, just shove the steering rack pivot location forward in the chassis, and rest assured that'll naturally put your Ackerman either back to 0 or you'll start reversing it. And you can easily just start fucking with that in the computer, by moving this interior point forward, and you'll see it'll cross a line real quick, and then you'll be in reverse Ackerman territory, and then you just decide how much do you want to go in that equation. And so again, like I'm saying, I am not a skilled enough driver to tell you that reverse Ackerman is going to make me win a race relative to having some Ackerman will make me win a race. I'm not that guy, and I never claim to be that guy. But I can tell you what to do if that's what you want. These are the methods we deploy to put reverse Ackerman into a system or to put Ackerman into a system. So if I want a fuckload more, or we have a client that wants more, we're going to be closer to this green pivot point while still pulling that rack back. I mean, you can put a fuckload of Ackerman into a system. And now with the steering rack, it's no different than a steering box. It's this point that you're focused on is what I'm referring to. So in a steering box or steering swinger situation, we're going to go to this. Steering swinger situation, it's this point right here, that position forward and aft in the chassis. So you just move your center link forward or aft. You know what I mean? That would be the same thing as me moving that rack. So if I wanted to pull this guy into reverse Ackerman, I'll shove this fucker forward, like 1.5 inches and start measuring from there and see what happens. Or maybe 1 inch, And so that is just, one example. Now, the other thing I like about, okay, so let's go over some positives with doing it the way I prefer, so to speak. One, I feel like the toe curve is a little smoother. So keep in mind, I am a little closer to the blue dot here than the green dot. And that is like this line right here. 2, this rack comes rearward into the chassis. We get a little bit better approach clearance. I don't want to say approach like angle. I mean, it's kind of like an approach angle per se, but I just like to say clearance because like you're typically might just, you're roughing stuff up. So, sand, dirt, mud, whatever you're going through at the time, maybe you can gain 1 inch or 2 of clearance in that very forward leading edge. So again, there's a positive right there. Now let's talk some of the negatives, so to speak, in this situation. Because you can't just fucking, just like I've said before, you can't just willy-nilly shove that fucker back indiscriminately. One, you're going to get to a point where the Ackerman is just fucking out of control. Oh, and let's review that too real quick before we move forward. like I was saying, most of the stuff I set up for most drivers is going to be between 2, maybe 5 degrees on the high side of Ackerman. So in other words, the interior tire is turning at full lock and ride height between 2 to 5 degrees faster than the exterior. With my experience, I feel like the majority of drivers feel comfortable in that range. Now, I am not a fan of higher Ackerman numbers. I have done higher Ackerman numbers, but I am not a big fan of that for a few reasons. One, I feel like that literally only complements stuff at lower turning speeds, and it can cause some unpleasantries at speed in these big trucks. One is you only have so much that you can turn in these trucks, especially if you have vertical bearings for your uprights. Now, if you have horizontal bearings for the uprights, you will have a little bit more turning capacity, but you're still not going to be like a drift car where you have 74 fucking degrees. You're going to be in like the 30s to mid-high 30s range with horizontal bearings, depending on who you talk to and how they set it up. And for the vertical bearings, you're going to be in like the low 30 range. So with that said, you have to keep in mind there is a limit. Unlike, like for example, like the Departy truck we did, I did 74 degrees of turning on the interior tire. A fuckload. We're never going to see that in off-road. That's just not going to happen. So you have a limit on that interior tire turning. So if you start building a fuckload of Ackerman into your system for obvious reasons, let's go. For obvious reasons, a ton of it, this exterior tire is going to come short. So if you max this side out with a fuckload of Ackerman, you may only be maxing out that exterior tire like 18 degrees. Imagine coming into a turn at 18. You're going to start pushing. That truck's going to push pretty bad because all your weight is now shifting on the exterior tire, which has a really low number, relatively speaking, if you're maxing it out. Now, this is obviously not going to happen all the time. This is going to be in more of select times. But the point being is you have to always pay attention to the fact that you have a maximum. You're not like a fucking drift guy. You don't have 70-something degrees to work with. So that max could easily over-restrict that outside tire too much if you put too much Ackerman into the system. And vice versa. If you're coming into a turn, you've turned, now you're starting to correct. So in other words, I'm turning left, but I actually have the wheel to the right now. So we're in a slide. The weight distribution's on now the inverse side, so to speak. That tire is now turning faster than the exterior in a slide going left hand, but I'm turning this way. So I'm trying to go that way. But you see I'm getting at, like, you know, I mean, one of those deals. Now you're just dragging the fuck out of this tire. Again, like I'm saying, I'm not a fan of the higher Ackerman stuff. I feel like that's far more detrimental than the inverse side, which would be reverse Ackerman. Again, that's my opinion. I guarantee you'll find some people that disagree with me, and that's totally fine too. I'm not the professional driver to tell you what is going to have me win races. What I can tell you is how to build it into the system relative to your client or the driver that you're designing for, etc. So there's some good variation in that, but like I'm saying, I keep stuff mellow for the vast majority of guys we design for, and I feel like that 2 to 5 degree positive range is like just a good area for, you know, newer drivers or the majority of drivers, etc., etc. So yeah, so there's that. Now let's go back to, in the rear wheel drive truck rack placement and chassis, the negatives. So that rant is over. So the negatives here, well, I mean, they're going to be very obvious right off the bat. First and foremost, you will notice the lower arm pivot, although covered by the upright, is significantly farther forward than the pivot on the chassis. So this creates a situation where we have to dive this arm forward. What that means is this rack, you have to make sure it clears at compression this arm. So you got to watch for that. At full compression and full lock, you got to make sure this rack does not touch your arm. Otherwise, you're going to have a bad fucking day. And the inverse side of the table, at full lock and full extension, you have to check the upper arm. Let me pull, let's see, rear wheel drive front end. Let me pull an example just so that, cool. So when this guy's at full lock, this upper arm at extension has to clear. This cutout right here is basically for that. And this lower arm is straight coming off of this guy and then kicks forward. And he kicks after this guy is at full lock and compression, so it clears. So there's one of the things that you got to watch for when you're doing a steering rack setup in a truck like this, when you are doing it in my style, which is placing the rack rearward in the chassis to build some Ackerman into the system, because I like to keep the pivot on the upright a little closer to the inclination angle. Make sense? So those are things you got to watch for. Now, additionally, you also need to watch for steering with shocks. So this guy's going to want to come out to about here because he's got 3 inches of throw. And at full extension, you got to make sure this bypass, or if your coilover's up front, doesn't tap that guy. So again, this just comes back to always double fucking, triple fucking, quadruple checking everything. Move that thing in the computer a million fucking times. Trust me, the more you do that, not only will you understand how things move better, but it's fuckload easier to change in the computer than to get a phone call after everything is going on the truck and something's hitting. Trust me, just figure it out. Take the time, try and get a good understanding of all this little bullshit, and take notes and note where you need to move, what you saw, what's too close. I like to always have a good chunk too. So if I'm like an 1/8 inch from the steering rack, I feel like that's too close. You kind of want to always be like a 1/4, 3/8 minimum, clearance, because shit moves in real life, so you don't want to just assume that the fabricators are going to be perfect at the end of the day relative to what I have here in the computer. So you got to build some variance in there for fuckery, tolerant stacking, weld movement, all that bullshit, and so like if the chassis doesn't quite line up to where this shock mount ends up, a little bit further forward by 60 thousandths, and this rack spot is just a hair, offset too, but I already have 3/8 of an inch of coverage in the computer. So at the end of the day, it becomes like 0.15 or 0.18 or 3/16 clearance. Okay, cool. We still cleared, but like I mitigated that by making sure I'm a little bit on the conservative side with my clearances. And so like that's something you definitely have to look for when it comes to moving that rack rearward. Now, swingers, it's way easier to mitigate because with swingers, let me see if I can find one of my swinger setups real quick. The swingers just don't take up as much room in this chunk of the chassis, because you have to remember, here's my pivot. Look at how deep the rack is. That right there is a good chunk. The swingers are going to be up here. So typically with swingers, you get a lot more clearance. So with the swinger system, you can mount the shocks further forward in the chassis. You can make the upper arm a little bit more swoopy. So you can get away with some stuff like that. With the rack-based trucks, you just have to watch for this stuff when it comes to that setup. And location on the upright, again, you're putting that either a hair outside of the inclination or a little bit more than that. And that would be up to designer builder preference, so to speak. Also with what you're seeing in the computer. Like I said, if you get too greedy and you're kissing that rotor, you might see that toe curve gets a little choppy for your liking. And if that toe curve is a little too choppy, feel free to go ahead and bring that closer to the inclination angle and just start moving your rack rearward to keep the same amount of Ackerman that you would prefer. So, again, just some food for thought. All-wheel drive. I'm doing the all-wheel drive stuff very similar. The problem with all-wheel drive stuff, I think I had... There we go. So this is a Mason. So his is relatively close to that inclination angle. And they do have their swingers and obviously in front of the differential and decently further forward. And I don't know specifics, but I wouldn't be surprised if they are either close to parallel, possibly reverse Ackerman, or very low Ackerman. Very low. Would be my guess just by looking at a few things really quickly from them. I obviously don't have their numbers. Maybe if you ask Neil or Robert, they might tell you. Maybe they won't, because that could totally be considered proprietary to them. Which, again, everyone has their own philosophies and thoughts, so you got to respect that too with the builders. I can tell you one thing is the Mason guys are fucking winning. So they're doing something right. And okay, so this does not look like full lock to me. This looks like he's maybe 70% into that turning cycle. And it would appear in this photo, it appears he is close to reverse Ackerman, maybe parallel. It's close. It certainly is not a high degree of Ackerman. That's for sure. So it would have the appearance that might be the case. And also judging by what I saw with this right here and what I know about the differentials and swingers clearance issues would lead me to believe they're in that range per se. The problem with an all-wheel drive really stems from the fact that you have this fucking gear set in your way. So unlike the rear-wheel drive trucks, obviously I can shove this rack rearward, and I don't have this gear set here, just fucking sitting there. On the all-wheel drive setups, let's see here, non-portal front end. There we go. So we have this gear set here, the front differential, that's in the way, which obviously means the steering rack gets shoved forward. That point gets shoved forward, typically speaking. And so it's really hard to have this point rearward in the chassis to utilize that tactic and deploy that method for gaining Ackerman into the system, if that is something you want into the system. Again, I do stress that. There are guys that do not want Ackerman at all. They want reverse Ackerman, to be crystal clear. And so that right there is one of the headaches that you have to mitigate. Now, you can also say, and to be fair, why can't I just take this point right here and shove it really far off the upright? Well, you can move him outboard, away from the upright or forward in the chassis, but you're going to find that now you're really fucking with your turning radius, your maximum amount you're able to turn, because that leverage arm and your rack stroke or swinger throw is going to be the determining factor for how much you can have max turn. So it's not like I can just willy-nilly put my rack and then just move him where I want. No, you're going to find that you're going to fuck yourself up pretty bad if you're not paying attention to that leverage ratio as well. So you got to make sure you get that dialed in too. And I'll go into a little bit more detail on that. So all-wheel drive, fright difference. Okay, so here's the other thing too. With the diff placement on the all-wheel drives, what you're really fighting, and here's the other bit to that. Let me get that guy open. That's not the all-wheel drive. God damn it. Here we go. So what you might be thinking to yourself is, well, if I want to get this steering point in the chassis rearward, why don't we just move the differential rearward? Fucking genius, right? I got it now. I'm going to, I'm going to add Ackerman. You know what I'm going to do? We're just going to move that diff rearward. That's right. Fucking got you, bro. Now I can do the same thing you were just talking about with the rack. Boom, done. Well, no. You're going to get fucked real quick. That differential center point cannot just indiscriminately move rearward in the chassis without completely fucking up, primarily speaking, the extension travel characteristics and numbers. Because when it comes to all-wheel drives, especially non-portal all-wheel drives, but also portal all-wheel drives, the extension travel and full lock, down and out, is where you're going to see the most extreme CV angles. You need to mitigate that as best you can. By moving that differential rearward, you're just fucking adding to that extremity. You're not mitigating that angle. You're making it worse. So you're either going to have to do one of two things. If you start moving that differential rearward then more than like a fucking 400th thou or half inch, what you're going to find is that the extension and at lock, you're going to either have to reduce your turning radius and wheel travel, or you need to put the differential back in a more complementary position. So again, you can't just start moving shit around thinking that I'm going to mitigate one scenario by doing this. Every fucking thing you touch is going to change something else. And that can have disastrous results, or it can have mediocre results, i.e. it's a fucking trade-off. I'm okay with X, Y, or Z to gain this. In this situation, maybe I will move that differential back 3/4 of an inch, and I'll lose 1/2 inch, 0.75 of usable wheel travel at extension. Maybe I'm at 19.9, or maybe I'm at 20 inches and I go to 19 and change. But what I did gain is 1.5 degrees of positive Ackerman, which is what my client was really concerned with. He wanted to be as close as he can to 2 degrees of Ackerman. You see where I'm going with that? There's these tactics you can deploy on different sides of the table to get us where we want, and do so in theory without too much damage to something else. And as long as you're upfront with the client, the builder, or whoever you're working with, that, hey, you know, I understand you have this metric, but right now, here's where we're coming up to this sort of wall. Now, I can move the wall, but that wall is going to move other stuff too. So, like I just said, I can mitigate that by putting the differential back where I want, letting the travel hang, and, you know, keeping this closer to 0 or maybe negative Ackerman. Now, there are some good theories too, in that parallel or negative Ackerman is better for all-wheel drive trucks as well. So again, there are different strokes for different folks. And the one thing too is, it's also theorized, and I don't know if anyone who has actually measured this, it would be very difficult to measure per se, other than the feedback or feeling from said driver, is that Ackerman in an all-wheel drive can introduce a feeling like torque steer, because you have too much of a variation in the forward drive tires, and as you're going through stuff, if one grabs, it could torque steer. It could cause that sort of effect or feeling to the driver. So by keeping them parallel or slightly reversed, you could mitigate that. Now, again, I don't claim to be a good enough driver to even fucking feel that, but I do understand what some drivers would be referring to in that scenario if that were a complaint that does arise relative to what they feel. And with that said, it almost kind of comes into play because it's very hard to get those higher Ackerman numbers appropriately in all-wheel drive trucks by default of a differential literally being in the fucking way. Let's see. So those are and it's still bad too with, and I did the best I could to mitigate some of that on a portal front end that I designed. So here's the reason why I would say like the Mason would be in that category of close to parallel, if not slightly negative. They're fairly forward of the differential in that assembly. And again, that doesn't mean it's wrong. They're fairly forward, and they're fairly, there's a good shot. Not far outboard of that inclination angle. Like this is where I like it, to be perfectly honest. That is a good spot or a good reference for what I would consider toe curve fuckery mitigation. Smoothing out that curve. That's a nice location. But yeah, so like here's the towers one. And it's hard to tell, but this is the steering point. It is tucked into this little corner. So I did the best I could to get a good number in there for our client and direction that he wants to go in. And again, I don't want to disclose the specifics on this, but I can tell you it is definitely not high Ackerman or mid-range Ackerman. He's on the lower side, maybe lower, but we have it in a specific spot. And this swinger setup is designed also in a fashion to create a very good Ackerman, so to speak, when you're in rough stuff through turn. One side's compressed and one side is extended. If you understand where I'm going with that, you're getting into something and the truck's like that. And with the swinger geometry, you can make those two things complement each other really fucking well. Which you can't do with a rack. So there's a fucking trade-off that we're about to go through as well. But my point being is you can look closely that I have this is where the steering mounts on the other side. This is just the passenger side. It's tucked in this little corner, so to speak, to get me as far rearward in the chassis without moving that differential and fucking up the other aspects that you don't want to fuck up. Extension and lock on that CV. I talked about the torque steer with that. Oh, long travel kits in Ackerman. Okay. It's fucked. It's that simple. So in the long travel stuff, like I had mentioned last episode, wheelbase changes and stuff like that tend to fuck with you in that aspect, because I'm going to use Blitzkrieg again. I've been boys with Nate for a long time. I know I keep using him as an example. He makes a lot of good kits, dude. So credit where credit is due. Fuck, I am trying to think when Blitzkrieg started. Fuck. Like 2003 or maybe 99 range. You know, Nate could, if you see this, text me, let me know. But he's a little older than me, to be fair. But he's been doing this a long time. And so, God, he's had a ton of fucking guys with kits. And I mean like decades on kits. So, again, just one of many manufacturers. You also have, you know, HM is another older manufacturer. Kevin's been around for just as long as Nate, if not maybe longer. Camberg has been around for just as long as Nate, if not longer. Missoula is newer, so to speak, than Blitzkrieg, but he's kind of getting old. I mean, he's like my age now. So Chris is definitely in the older crowd to some degree. On the younger side would be like Izzy Fabrication. He's a little bit younger. Ryan Kibb, I think he's a little younger than me. I'll have to ask Ryan, but I'm pretty sure he's a little younger than I am. I don't think he's older than I am. So he's like a mid-range oldness scale. But the point being is a lot of long travel kits have come from Blitzkrieg for various applications and things like that. So now let's talk about Ackerman fuckery with long travel kits. The main thing that really sucks with long travel kits is you're using a stock rack. And so when doing so, those fuckers are wide from the factory, relatively speaking. And so you're basically forced to shove this steering point. So, okay, here's how it works. When I'm designing a long travel kit for a stock vehicle, it's the inverse, so to speak, as if I was doing it for a center mount. On a center mount, I like to go from the upright inward. So I would start with stuff here and work inward. On the long travel kit, you're stuck with the inboard side because, again, the factory has placed that rack in that point, so fuck you, right? You have to take that and then mitigate your toe curve fuckery based on the upright side now. So depending on how fucking greedy or not greedy you get with your scrub and inclination and camber curve and all this stuff, you're going to basically take this point and start plopping him as best you can to mitigate that. He's going to end up close as fuck to that rotor, for sure. High probability you will have Ackerman in the system. High probability, combined with the fact that most likely, due to wheelbase mitigation, you are going to be moving that entire upright forward, thus creating that same effect I referred to earlier, where this point in the chassis is rearward than this point. So the street trucks or long travel trucks typically always end up with some degree of Ackerman. And I think that is generally a good thing, because driving on the street, you would want more Ackerman, so to speak, than not. Which also leads me back to some of these Ackerman examples I had in this folder right here. This is the Robbie one. Here you go. This is a geyser. This does appear to be fairly parallel, possibly negative. Possibly negative. It is difficult to tell. This is the SST truck. Robbie will chew my head off for showing that. Well, whatever. He did a good job on those things. They're fucking rad. Robbie thinks different than a lot of guys. He definitely does. This is an ID truck, and it's hard to tell because this is relatively early in the cycle of the steering. In other words, like he's nowhere near lock, but it does look like Dave has put some Ackerman into this system. This is BJ's truck. So I would say there's some Ackerman in this system. You can slightly tell based on that picture. Here's another picture where you can see your inclination angle, and you can see the pivot slightly outboard of that. This is BJ's other ID truck. That is a SST truck. There's Robbie's truck. Here's another ID, BJ's. This is a different angle, etc. And see, in this one, again, it's really hard to tell in some of these situations. This one almost looks negative. Almost looks like it's got some negative Ackerman. Or that could very well be what we're seeing is slight toe change at extension. Could very well be. So both of those can kind of play a mind fuck on you when you're looking at pictures like this, so it's hard to tell. This one looks fairly parallel-ish. Parallel. Again, not huge amounts of Ackerman. One thing you are noticing a trend of is we're not seeing massive Ackerman like you would see a drift truck or whatever. So if you see an off-road truck that's doing one of those things, that's not ideal. So yeah, so just going through some of that real quick. So back to this. On this, like I said, our interior is typically set, so our exterior is what we got to fuck with. So we're going to place that point, and we're going to cycle appropriately until we can get him dialed in. And now, on these long travel kits, you're never going to get the tow curve to be near as nice as a center mount. It just ain't going to fucking happen. You know, I don't care how much time you spend on it, etc. You just want to get it to be as least fucked as possible. But these trucks are going to inherently have bump steer. You're never going to get rid of it. If anyone has a long travel truck and says they have zero bump steer, that is a massive fucking red flag. If they even have a center mount truck and say that, again, that's a fucking red flag. But the point being is, if they know what they're talking about and understand the true dynamics of the stuff, what they're going to tell you is, no, what I'm working on is making the tow curve as smooth as possible and as predictable as possible. That is the mitigation of any negative side effects. And so with that said, that's why these long travel kits, typically speaking, become a little bit more of a pain in the dick to design than a center mount, because you're fighting that stock stuff. And that can create these sort of headaches. Now, if you were to ditch that stock steering rack entirely and just start plotting your own points and plot your own point on the upright, etc., like you were to treat it like a center mount, then yes, you will definitely get a mitigated tow curve. It'll be a lot smoother, a lot less bump steer, and probably a little bit better party. But again, these guys typically do better. These streetable trucks typically do better with some Ackerman in them. I also think they have a little Ackerman in the SST trucks too, but to be fair, they are running those on a lot of pavement as well. And so I feel like that was something they put in there. And someone could correct me on that, because it's been a while since I've seen the SSTs in person. So I'm kind of just trying to remember off the top of my head on that. But again, different strokes for different folks. Unless it's long travel stuff, you're kind of fucked, because you're stuck just doing the best you can to mitigate that tow change just in general relative to trying to play with the other manipulations. So yeah, and again, by moving the wheelbase, moving the upright forward, like in this is an all-wheel drive, you can't get too greedy with these, because again, you're going to run into the same thing like the center mounts, where your axle is going to get fucked. Your extension and CV at lock is going to get fucked if you move it too far forward, because you're adding to that angle, and the CV is everyone designing these things is already kind of stressing those, to be perfectly honest. And so you're kind of just making that worse, or you have to strap it up now too much. So you might lose more wheel travel in a system like an all-wheel drive like this, where you're already, struggling to get as much as you can wheel travel right. See, 16 inches. That is. See, Nate does a good job of this. 16 inches, you might be like, oh, that ain't fucking shit. Like, my boy over here gets 20 inches in his long travel kit, blah, blah. Nah, fuck your boy. 16 inches of usable wheel travel in a four-wheel drive truck like this is fucking rad, dude. These things actually do work pretty well. Nate did a great job of these, and they do use stock pivots. So this is about as optimized as you're going to get using stock pivots for an all-wheel drive truck. Like, you're really not going to fucking optimize anymore. I bet you if I just went from a blank slate and fucking started drawing something in the computer, and then I gave Nate that CAD file, he'll be like, this is pretty fucking close. Because we're going to be optimizing in the same generalities. And I would be fine with 16 inches of usable as well, which leads me to believe that we're going to end up very similar circumstances, because I would be, again, stock pivots, stock stuff on the wheel and tire, and mitigation with the camber curve relative to the inclination. You can tell he's mitigating that some by opening up that scrub. I talked about that last time. And we would still have to mitigate the same steering, i.e. that pivot on the interior doesn't change for Nate or I. So the exterior is what we got to fuck with. You see what I'm getting at? By default, we're going to still probably end up super fucking close by just going off of those generalities and bringing us back to that side of the table. So yeah, so on the rear wheel drive or non-all-wheel drive long travel stuff, you can move that upright more typically, and you'll start to induce more Ackerman into that system. Let's find one of Nate's two-wheel drive setups. I can't tell. Is this one? Yeah, this one. This is the Raptor two-wheel drive kit. And it's hard to tell, but it looks like this is definitely further rearward in the chassis than this. So he's probably got some decent Ackerman built into this system, just as is. And you can see right here, here's some of the, again, the stock stuff sucks. It fucking sucks sometimes. At compression, he's got this pocket built in because this bad boy has a decent throw on him to where if he didn't put this pocket in there, he'd probably be hitting, would be my guess. 2.5 coilovers, 4-inch bypass, 17 inches of travel. See, this is exactly what I was referring to last episode. 93.9, that is a good number. That is a good range right there. 17 and change usable wheel travel with a 94-inch track width. If you can't get the truck to do what you want to do like this, other than like I'm going to a center mount or trophy truck, then you just don't have the skill set to be driving this truck per se. That is plenty of wheel travel, and that is going to work just fine, especially with that big of a fucking bypass up front on this bad boy. So that's a good job, Nate. Good job. This is actually not far off of like what HM's new stuff is too, which I helped Kevin with that, the newer generation of HM stuff that he's just now getting to market. But anyways, like here's another example of Nate's stuff. I think Kevin is on. Let's see. HM Racing Design. He just his Instagram got fucking hacked, and so he had to put a new one. Let me see. Oh, there we go. Let's see if he has any of the new Raptor stuff. There's one of the new arms for one of his Raptor kits. One of them that's like the more mellow one. Here's some of his other Raptor kits. Here's one right here. The Elite two-wheel drive setup. Yeah, and this is that similar range. I don't think this was going above 18, if I remember correctly. It's like right in that range, and this is right at like 94-inch track width as well. So again, just back to what I was saying is these are like some of those generalities. So let's go back to steering racks and steering rack setups. Where are we at on time? Jesus Christ. Fucking hour and 20. I need to hurry up. Okay. And I feel like I'm still like intentionally missing stuff too. Okay, so let's bring this up. That is, so these are steering racks right here. Sorry, as my wife is messaging me. Just wanted to make sure it's not an emergency or any bullshit I got to jump off this to deal with. You might be able to still hear the toddler yelling in the background. But, okay, so here's the steering rack. Here's our rack adapter, etc. So these move in a linear fashion. There is nothing I or any other designer can do to change that. They go side to side. And with that said, that is a limitation. However, there are very competitive trucks that do win races like every single fucking weekend. In fact, the Baja 500 is on right now. And yeah, I'm watching it live. They're still racing. But the point being is the degrees of freedom that I can adjust on this rack in relationship to where I put that steering pivot is obviously a lot less than a steering swinger setup. What I could control is the depth away from the rack or in the chassis, the height, and the width. Now, as I alluded to earlier, the depth in the chassis is going to be more of a characteristic of Ackerman as opposed to mitigation of that toe curve fuckery. The height and the width are the two that are going to have the biggest mitigation of the toe curve fuckery. And so keep that in mind. Those three things are what you're manipulating when it comes to placing it on the steering rack. And I already mentioned like the height in the chassis is a big deal because that can fuck you up. The height of it is important for two reasons. One, you obviously are going to have clearance on your lower arm and clearance on the upper arm. The other reason is when you're doing this, I prefer to keep these pivots as centered on the rack main bar, so to speak, as possible so that you don't have it too far offset below or above. Now you can get away with a little bit of offset, 1/4 inch there, 1/2 inch there. Like this one I think is like a 1/4 inch. And stuff like that is fine. But we'll get into this in a second. So yeah, so there is and I'll get into what these are specifically later in the construction section. But let's focus on those 3 measurements. So forward aft would be Ackerman. Height in the chassis, up and down, so to speak, and width in the chassis are going to be our toe curve mitigation tactics. And like I had showed you in that previous image, here, this is the width in the chassis and the height, so to speak, and you're going to match that to some degree. So these are kind of like some generalities of what we're looking for in that rack deal. And now, where was I just going with this? Oh, yeah, the offset. So the offset, again, like I was saying, you can offset it down a hair. You can offset it up a hair. Typically, I avoid offsetting it up. I usually only end up offsetting it down, naturally speaking, because you do want to have, or my preference is, to be crystal clear, to have the location for the steering to be as low as possible on the upright. Now, you'll note, like this one is higher. You'll notice there is a weird caveat with steering rack trucks versus swinger trucks. Like this is a swinger upright for one of our DIY setups. That location is significantly lower in the upright. This one is a steering rack setup. It is higher on the upright. Let's see if I can find anything else. I don't remember what Armada is running in this, to be perfectly honest. That is relatively low. So I don't remember. I'd have to ask Igor on that. This one is a rack base setup, so he's a little higher on the upright. A rack base setup, so it's higher on the upright. Rack base setup, rack base setup. Steering swinger setup, so a little bit lower on the upright. Let's look at, man, there's a ton of uprights in here. Let's go back to the top, see some other examples that aren't mine. Again, Mason, a little higher on the upright, rack base. So the reason that you typically see the rack base stuff higher on the upright is because the rack has to be a little higher in the chassis, thus making that pivot for the rack a little higher in the chassis. And if you don't offset it a ton in the rack adapter, you are inherently going to have a higher point on the upright. So naturally speaking, that's why you see the rack-based uprights typically have a steering point higher up on the upright. Now, you want it lower on the upright. In theory, you want it as close as you can to wheel center line, but you're not going to be able to do that in the perfect world with off-road, so we do the best we can. These racks are pretty fucking stout, generally speaking, so even with it high in the upright, like this is a Mason truck, or like a bunch of this shit we've done, like this is a Pro-Am based upright. It's not a Pro-Am upright, I'm sorry. It's a Pro-Am, it's an upright that was designed for a Pro-Am rack. This one, too. There's an ID one, Dave ID. This one was for exterior swingers. This one is for a PSS rack. But so inherently speaking, what happens is the rack point ends up higher because we want to put that as centered on that rack main bar, so to speak, or the main slider as best we can. So that will inherently put us higher on the upright. Whereas the steering swingers, we can tuck those motherfuckers down, you know, and get us much lower on the upright for a better leverage ratio, so to speak, or better use of the energy expenditure by the steering linkage, if that makes sense. And so those are two inherent things that kind of happen when it comes to rack placement versus steering swinger placement. So that is one of those natural things that dictates that location on the upright in the rack-based trucks. And, okay, so keep going. Depth in chassis, height in chassis. Yeah, I went over that. The height in the chassis, lower arm compression can be an issue. So you always got to watch this bad boy. Location on the upright, height and distance from the upright, leverage ratio. Oh, so yeah, so we went through the height on the upright. Let's talk that leverage ratio for the steering arm. Let's talk this depth again. And I did hint on that earlier. So like I was saying, you got to be careful with this fucker too. So what you want to do is your client, oh, here's a perfect example. Let me see if I can find it. You may have clients that are specific with what do they want their turning ratio to be, or turning lock to be at ride height is typically what they're referring to, or that's what I like to use. HP high performance HP heli HP heli. Fuckers. HP heli, guys. Bear with me for 1 second, guys. I need to find this because now it's just gonna piss me off if I don't find it. So just give me a second. So there we go. Oh, son of a bitch! They're not tagged in this. I'm trying to find their page. HP high performance helicopters. There we go. This is what I was trying to find. Thank you for the patience. So let's see if we can find my example. So this truck right here has an older stage 2 DIY setup on the front. It is vertical bearings, so the steering is a little bit less than what we would do if we had horizontal bearings, and I will get to that section in a little bit here. But the point being is I just redesigned their front end of their trophy truck, but at the same time, the front end of their trophy truck will now also bolt on to the front end of this truck, so they can add to that. And in doing so, we changed the steering leverage arm ratio to gain some turn at ride height. So let's pull that up. What we did is, because it was a vertical bearing setup, in fact, it's very similar to this kit right here, we only have so much I can turn here before that bearing ceases. And at extension and lock, that's typically where you find the biggest problem. But my point being is you're going to have a limit there. And that limit is going to dictate what this length can max out at relative to your stroke. So on the PSS rack that has a 6-inch stroke, that gives us 3 inches on this driver's side. That means I can do the quackulations to where this arm right here, so to speak, from center, we can make this distance optimized so that this bearing only ever so slightly gets just a hair below max, like 2 degrees below max, at that 3 inches of throw. So we're maximizing that bearing articulation. Now in a horizontal bearing setup, let's see if I have one pictured in this pack. Here's a horizontal bearing. These are both horizontal bearing setups. The bearings are in the different direction, so they can turn almost fucking 360 in theory. So they're not limited by what I was just referring to. So with that said, on the new front end that is going on those guys' trophy truck, it's an older truck that they just cut the front end off and they're putting a new one on. They specifically wanted me to add about 5 or 6 degrees of turn to full lock. And in doing so, we didn't change the rack. So it's still a Power Steering Solutions rack, and it's still the same throw. What we changed is this leverage arm ratio. This arm became shorter. So with the horizontal bearing up here, I'm not limited by that bad boy. So we were able to push this guy to like 36 degrees. I don't remember the specific number. I would have to go pull that up. But the point being is we added 5 or 6 degrees to it versus the vertical bearing setup by changing the length of that leverage arm. And in doing so, we also pull some Ackerman out of the system. That is inherent how that works, because now this point is moving rearward in the chassis relative to this point. So it kind of does the same thing. Now you can mitigate that by, again, moving him more outboard and things along those lines. So for obvious reasons, that was part of the stuff I was just referring to. But what we want to focus on with this right now is that leverage ratio on the arm, these steering tabs on the arm, this length has a few things that you can play with. And they all are very specific to the throw of the rack and the degrees of turn that you want or are allowed to have, i.e. on the vertical bearing, I can only have so much before that guy maxes out, and then you're basically just going to fucking start binding shit in the steering. And you don't want that. That's a bad phone call for sure from a client. And at the same time, you have to keep in mind as that decreases, to increase your steering, like in a situation like this, that point does move rearward in the chassis, thus it starts to decrease Ackerman in your system if the rack doesn't move as well. So keep that in mind. Location on the upright, inboard, outboard. Map out the travel from the front. Yeah, so now that you kind of understand this stuff, we can review what we do here at Tekk, because we fucking cheat, to put it simply, than what I used to do in the old-fashioned days. Let's see, rack. Pow! Some cheating going on here. Some fancy SolidWorks manipulation. So these quackulations are very straightforward. So what happens in these instances, I have a camber and caster curve that I've already figured out and I'm happy with. We're fucking kosher. Then we go in, and what you're seeing here is we're plugging in these sort of, this little star point bullshit right here is our toe curve. So we're plugging that in, and what the computer then does is it optimizes that steering point. Now, we set that steering point within the chassis. We set this leverage ratio on the arm so we understand our steering lock on that. And we also will set the height. So in other words, like I want him centered on the rack. And then so what the computer does is then optimize the open variable, so to speak. So it'll optimize the height of this guy, how far outboard he is of inclination, and the width of this guy in the chassis. And then obviously the length of our deal. So we'll take this computer simulation, so to speak, and we will dictate, like, here's another one. This one's an all-wheel drive one. And I will dictate, here's the toe curve I want. And here is where I want it set at, obviously, ride height, the toe, and compression, and stuff like that. And then the computer will quackulate that interior point relative to those open dimensions, and gets us basically spot fucking on with very little work to some degree. Also, we've done so many of these that it's not difficult to map that. This is just a top view of it mapping. You can see it moving through travel. This is what I was referring to earlier about taking the leading edge. So these are all the points of the leading edge of the tire relative to the trailing edge of the tire. So that's right there is how we're measuring. So, again, total fucking cheating, huh? And so the best way to do this by hand, or if I was going to start the old-fashioned way, is I'm going to go back to what I was referencing before with this. I'm going to go back to this guy, start here, maybe move him out a little bit, see where my Ackerman is, make sure your leverage ratio on the upright is correct for your turning radius relative to your rack throw, and then I'm going to start cycling it. So I'm going to do this at ride height first to dial in the leverage ratio on the upright, so our turning lock relative to throw on the steering system, whether it's a rack or not. So we'll do that at ride height. We'll get him. Then we'll get our Ackerman figured out, how I like that or not like that. Then I'll start cycling it, and then I'll start manipulating the points through cycle, like the interior and the exterior, to dial in my toe curve. And that just takes a lot of time. So what we've done at Tekk is we have our own like sort of sketch programs in SolidWorks that helps us do this a lot faster. And so I am, in essence, cheating, to be frank. And this is only looking at it in a rack scenario, forward on, so to speak. Now, In this one, it is done in through turn as well. That's where you're seeing this guy right here pop up. So all these flat ones are straight on, and then this one will be through turn. So you can do the same thing through turn as well with a rack. It's just you don't want to. Well, here's my opinion per se. Like in the rack scenario, you're going to maximize this sort of forward-looking or the straight toe curve as best you can, and then just check the in-turn one. But the in-turn one is not going to be great. There's no way. You don't have enough degrees of freedom in a steering rack assembly to mitigate that because it moves in a linear fashion. You're never going to have the greatest in-turn toe mitigation. It's just not going to happen. So just keep that in mind so you don't pull your fucking hair out, think you're fucked up, you're an idiot or anything. No, it's just, it is what it is. So even the big boy fucking trucks you see that run steering racks, they have this. It's just inherent because it's a linear movement. It's not an arc movement like swingers are an arc movement. So yeah. So map out travel, note the desired location, note the desired turning radius. Yep, we reviewed that. Leverage arm on the upright, we reviewed that. Note the Ackerman, changes with speed, we reviewed that. Placement on the upright front view, we reviewed that. Screenshots, well, here are the screenshots. I'm just going through my, just making sure I'm not going to miss anything. Yeah, we reviewed that. So yeah, you can kind of see some of our trickery / fuckery / lazy as shit stuff. Steering racks, common racks. I'll reveal more of that, but the companies that I tend to favor, Charlie at Power Steering Solutions has been fucking rad to work with. How, another great company. Pro-Am has made great racks for a long time. Roy is pretty fucking cool. And they are a little bit on the more expensive side, typically speaking, but the Pro-Am is a nice piece. You cannot knock Roy for that. He does make a quality steering rack. And we have used some Fortin stuff. A buddy of mine, John Addison, is running a Fortin rack in his 7200. So that is Doug Fortin. We don't use Fortin stuff as much as the others. I would say the vast majority of stuff is either going to be HOW or PSS by default, simply because Pro-Am is typically more expensive. Some of the more hardcore stuff might be leaning a little closer to Pro-Am. Budgetary constraints usually depict that. And then Fortin, I'm trying to remember, I think Addison wanted that specifically. Or we've had some buggy guys run Fortin stuff too. They're all quality stuff in their given applications, to be fair, because they're not all the same. They're different sizes and different usages per se relative to the specific truck or application you're building. And then for stock stuff, well, you're kind of fucked. I mean, there isn't like really great replacement stock racks in a lot of these types of vehicles. There are guys that are doing, like Blitzkrieg has done swing set steering for Silverados. Izzy Fab has done swing set steering for Silverados. I actually helped them with that. Ryan Kibb has done swing set steering for Silverados, but we're going to get into that. So they're not really doing replacement racks, although Izzy Fab has a like a rack mitigation deal where they're supplementing the rack casing strength-wise and robustness. But like you're not going to HOW or Power Steering Solutions or Pro-Am and buying like a rack that you would put in a Silverado long travel truck or a Raptor, so to speak. You're basically using the stock shit for the most part. I'm sure you could find someone that has done that, so to be fair. Now, let's move on to steering box fuckery. The cool thing with steering boxes is it gives designers like me more degrees of freedom to fuck with. And I hate it. It's a love-hate relationship. I used to be scared as fuck with it, and I would, this is years ago. I used to basically only tell clients to run racks, or I don't want to design a steering swinger setup because I knew it was just going to be far more complex. Now that I've done it a bunch of times, I don't think it's nearly complex. Obviously speaking, with more experience, that natural feeling comes into place. But the reality is it definitely is more complex. And there's a lot of cool shit you can do, which is even more fucking rad once you start to understand how it works and how it moves. And so I get excited with that because you start to dive into just changing so much different cool shit through the steering rack stuff. I fucking love it. So just like everything we do here at Tekk, we try to find the laziest fucking way we can do it. And we create these sort of programs. And so here is one here that is mapping out the steering of an inconsistent caster all-wheel drive front end that is actually on the front of a Class 1 car. This does have rake built into the system. This is a steering swinger setup. And you can see, so camber and caster curves, I have all that dictated. Everything's fucking kosher. And then I go and dictate our turning lock relative to the throw that I want. So I've got that set. And then now I'm going in and manipulating our toe curve and setting that and getting the computer to tell us, you can see all these blue lines, where the optimization point is for that center link setup. And again, that is just one of those things that like you just have to start going through it and do it. The best advice I can give you is, so here's another one. It's a non-all-wheel drive one. This is a rear-wheel drive one where we're mapping out all the locations through the toe curve, and that's optimizing that point relative. So steering swingers do not move in a linear fashion, and that's like the best fucking part about this is you can really open up that degree of freedom. The swingers obviously swing. They create an arc, and that arc is what you utilize to take the intern bump steer out of the equation. So let me give you a little bit of a glimpse into that cycle steering. Here we go. So so the middle here is a rack-based setup. The ones on the outside are steering swinger setups. So let's look closely at this middle one. This is a steering rack that is set up like I was just saying, and it's hard to mitigate some of the fuckery through turns, so don't stress yourself out on the rack because it moves in a linear fashion. Now look closely. Notice how the tire seems, this is at lock, mind you, through travel. The tire seems to move. The steering changes, so to speak. So it steers more at extension than it does at compression, and that's just how we have this geometry set up. Now, it moves really clean in a straight line, but once you get it in turn, the rack is going to be a little meh. There's no way around that, like I was saying. Now, look at the variance in a steering swinger setup. Look at how much more controlled that is. It's less difference in that tire or that change through turn travel. That's what you can mitigate with these steering swinger systems. So in-turn wheel travel definitely becomes a lot more badass with manipulating the arc of your swingers and things like that. So when I set up this stuff, now, well, no. When I set this stuff up, we're going this route where I am dictating in the computer my toe curve, in-turn, and everything like that. Like this one is actually doing it through turn right now. This one is doing it head-on. Like I said, it's cheating. So I'm getting it to optimize the point for me to get me to the specific toe curve I want, or as close to the fucking specific toe curve I want. Because they may not be perfect, but we'll get it damn fucking close to perfect. And with doing so, I'm skipping a lot of steps. So with a rack-based setup, here's another view angle of it. With a rack-based setup and this sort of swinger setup, we kind of start in the same direction. Let's focus on head-on, where we're starting. So we're still going to kind of come back to this initially, like you would. Pick your flavor, even though it's steering swingers on the interior side, kind of get it moving in a forward-looking direction as best you can first, right? If you're doing it in the direction that we're not doing it, so to speak, if you don't have the same sort of setup we have in SolidWorks, then what's going to happen is you kind of got to do it by hand. So you're gonna get it going in a straight direction first, and then focus on the through turn travel. Now, I can't simply just tell you what to do with the swingers and measurements because these are all going to be different. But what I can tell you is the best advice that was given to me a long time ago, especially when it came to this shit, is very simple. Put in the fucking work. And when I say put in the work, this is what I mean. I will show you right now. Rack steering, swing set steering. Right here. Map every fucking thing you change. All of it. And the things that you're going to be focused on are primarily going to be the length of your swinger, not now, fuckstick, not now. What the uses view only. There we go. Apparently they want some fucking money. Okay, so this is, without going into too much detail, this is for a trophy truck client. This is not necessarily where we ended up, etc. But I just want to show you some of the direction. This is an older spreadsheet, 4-degree swing plane, just kind of how you put in the fucking work, so to speak. And this is what I want you to do to give you a good idea of to how this stuff works, because it's not as simple as me just telling you, okay, put your swingers here and put it there. I mean, I could do that, or we would map it like this in the computer, and I could tell you that. But if you're designing it yourself, the best way here is you have to learn what your movements change relative to all the bullshit. So when I start manipulating the width of this center link, when I start manipulating the height of the swingers in the chassis, the height of the center link, the length of the swingers, the width at the top, the width at the bottom, very fucking important, by the way. You do not want parallel swingers. That I can tell you. Parallel swingers are only acceptable if you're trying to do that in like a stock application, like those Silverados I was referring to, and you have clearance issues. But if you're building a center mount and your swingers are parallel, you need to keep going. You did something wrong. And so with that said, here you go. Top spread of the swinger, bottom spread of the swinger, height of the swinger. Here's degrees, interior tire, steering angle, exterior tire. Here's our delta, etc. Start fucking mapping it and map it through all this different shit. You will start to see the patterns emerge. I'm not going to tell you where the patterns are, so I'm just not going to do that. That's some secret sauce that I feel like you can fucking do on your own by simply doing this. Start mapping it. Start moving this shit around. Like, here's a good example. Swing arm lower points below steering points, 4-degree angle. 2 inches. Top spread, 8 inches bottom spread. That is this measurement here, 2 inches apart here, 8 inches apart here, with a 15-inch height on the swinger. And here's our steering numbers. Here's our deltas. Again, you will start to see patterns emerge, and just keep going. And once you start to understand where things are going, you can start fucking. Here's a 0-degree swing plane. This is what you got to do. Put in the fucking work. There's no easy street to this. You just got to start mapping it. And you got to start doing it in a fashion that you understand. And I felt like this is a good fashion. So go ahead and fucking copy this format. I don't give a shit. Because this is not the secret sauce. This is hard work. This is hours and hours in the computer cycling and mapping this out, even with our SolidWorks-based program. So with that said, putting in the work is going to get you to where you need to be to understand what these changes and movements do. It'll help you understand what the length of the swinger is. It'll help you understand what the width of the swingers are and what that does to all this fuckery out here at the tire. So all of those things are not able to be adjusted in a steering rack. So these are the degrees of freedom we get to open up and fuck with in a steering swinger setup. So it becomes far more complex, but that complexity allows us to dictate through turn how we want that tire to be compared to a steering rack setup. So if you want to put in the time to do that, you totally can. Just like I was just showing you, you can start mapping this shit out. Start just fucking be the goddamn monkey and just start throwing darts at it and put that into an Excel spreadsheet, see what happens, and just start moving points, see what happens, move points, see what happens, until next thing you know, you've got a fucking Excel spreadsheet and all this different stuff where you can start viewing all the deltas. I think we may have just accidentally showed something I shouldn't have. We're not going to show that. But because I don't want you guys to know the specifics on some of this. I got to keep some of the secret sauce close to the hip as far as some of these more complex assemblies. But the point being is, I'm by no means a fucking rocket scientist. There are also a ton of other really smart guys that understand this and can do this too. I'm not the only one. But if you don't put in the work, you're not going to understand it in detail, so to speak, to be able to legitimately do this. And when you start to map this stuff out, you're going to notice these trends. And like I was saying, the parallel swingers is one trend you're going to notice real quick, is not kosher. So if your swingers are parallel, you're definitely going to want to keep going with that design, per se. Let's see where we're at. Steering box, adjust with different changes to the swingers, location on the upright. Yeah, I mean, location on the upright, like I was saying, I like to bring this down because I can bring this pivot much further lower in the chassis, so I can bring him lower on the upright and get that closer to wheel center line, that leverage a little bit better, stuff like that. So that's what I prefer. Some people could argue with me on that, but again, that's just a preference of mine. No desired turn radius, leverage arm ratio. So that stuff still applies with the swinger setup. You know, the distance from this point from the center of the upright, that arm is going to dictate the leverage ratio as well with turning. The other thing, too, is on these, the steering racks, like 6-inch throw is standard for a trophy truck. On these, you could go like a 7-inch throw with your center link. I have done that to get us a little bit more throw. And what that'll allow me to do is keep the same amount of steering, so to speak, but I can have a longer leverage arm on the upright now, which is... that's not a good picture. I can end up with a longer arm here with a steering swinger setup because I can move this to a 7-inch throw. Make sense? So again, this having a little bit better ratio, in essence, will provide a little bit more robustness to the system. So there are reasons why a steering swinger setup can end up being more robust inherently or by accident with that type of stuff. So, okay, cool. The other thing, too, is the rack is set to a ratio that the rack is designed for. In a steering swinger setup, we can manipulate the pitman arm and this guy as well. This is a traditional Saginaw box. This is not, so this is an older picture. This is an ID Designs truck. Dave, fucking rad. Guy is arguably one of the smartest guys in our industry. And if you ever get the pleasure of speaking to him, definitely do so. If you ever get the pleasure of looking at some of his trucks, definitely do so. It's fucking rad, man. You can totally geek out. But the point being here is he is similar in the same fashion I like. I do like this lower in the chassis. This is our center link pivot. He does like his swingers at that angle, so to speak. They are non-parallel swingers. He does like that lower down on the upright. This is a long sector shaft Saginaw box, more of a traditional one like you would find at Howe, etc. The more modern day trucks are running the PSS billet boxes. But let's focus on this pitman arm. So this is the pitman arm right there. Let's see if I have a picture of one of mine. Here's a pitman arm right here. And so you have the ability to change the length of this pitman arm, which will change the tightness of the steering. It won't change like the movement of this per se, because you're still going to maintain your center link to a certain throw you design into the system. So if I design this point to move that 7 inches of throw, 3.5 per side, I'm not going to just randomly start changing it with this. No. What you can do is use this length and the ratio in the box to manipulate how quick it turns relative to steering wheel turning. So you can use that ratio on that side of the table. You don't want to necessarily use that ratio to change the throw. You want to design the throw into the system first, and then you design the throw to match your ram, because your ram's going to have a throw to it that will not, well, it may not match the throw of the steering linkage. In my systems, they typically don't. So your ram will not match the throw of this guy, so you're going to have some geometry in that to make those be damn close to each other or perfect. And then you're going to have your pitman arm throw as well, relative to the steering box ratio. Now, steering racks come in different ratios too. So your steering rack will have a ratio as well, and that'll be how many turns you turn the wheel relative to it moving the rack back and forth. So those ratios, again, super driver specific and can easily be changed. So for example, if the driver of this specific truck feels like he wants the steering to be a little quicker, I would decrease the length of this pitman arm by like a 1/4 inch. If he wants it even quicker, maybe a 1/2 inch. And then I can quicken up that. If I want to do the inverse, I would lengthen it up, so to speak. So, like, I'll get into those later on, but like the ID one looks like he's a little shorter. So his, in theory, is turning a little quicker. So the ratio relative to the gear set in here and him may actually be the same as that power PSS one and that pitman arm I have down there. It could be possible because, again, you're playing with 2 different ratios. So you got to keep that in mind and make sure you quackulate accordingly for that. Again, same thing here. The throw of this guy right here is going to be more than the ram. We do use Dave's rams. I like his rams a lot. They're very robust. So in a lot of the steering swinger setups, I do opt for Dave's rams. So, and as far as the, so here's another version. Here's another pitman arm deal. Again, if I wanted to change or quicken this up, I can shorten this ratio a little bit. This one, we have the ram up top because this is for an all-wheel drive that has a differential right here. And here's our steering nice and low in this fucker. Here's just some FEA on some of the swingers that we did in-house. This is a fucking classic. Holy shit. This is the Simon. That is the Simon & Simon trophy truck, I believe. Rad as fuck. So this is a steering swinger setup. Here's that pitman arm. A little bit longer of a pitman arm. And he's got it to a setup in here that's hard to tell, but your center link pokes out right here. So that's your steering leaving right there. This looks like a Saginaw box too. This is another view of the steering system in the all-wheel drive. Our center link is here. Swinger. Again, you can see I have unparalleled swingers. You're going to notice a pattern with every time I'm doing this, we're doing unparalleled swingers for sure. Yeah, so swinger setups with inconsistent and consistent casters. So when I'm designing the swinger setups, the swinger plane, so to speak, I match that to the upper arm. I find that to be the most comfortable, so to speak, with getting my other quackulations in place. So if it's consistent caster, what that means is it's going to be parallel to the lower arm too. If it's inconsistent caster, or what some call caster gain or anti-dive, I like to match the plane of the swingers with the plane of the upper arm. Typically, when we start mapping that shit out in our spreadsheets, etc., I find that to be a little bit of a smoother arc, relatively speaking to an inconsistent caster setup. So that's just something to touch upon right there. And that's the plane of our swingers. So let me, I need to find a bulkhead to show you that. Hold, please. This will work for that example. So this is a bulkhead that's at 4 degrees of rake, but it's consistent caster. So this upper arm pivot, here's upper arm pivot right here, here's the upper arm pivot right there, actually matches the lower arm. They're parallel. The swingers mount kind of hard, but they mount behind this tube. They're in there. And they mount in plane, so they're on the same plane as the upper arm. That's what I am referring to. I want to keep my swinger plane matching the upper arm. I keep my pitman arm matching him too. So all of these are perpendicular and parallel to each other, you know, in the chassis. So if I go inconsistent caster, then yes, I would be leaning that more, so to speak. Also, you could have someone bitch that this guy's going to be pointing downward. And the reason I want him to be perfectly perpendicular to the swinger is because if he's not perpendicular to the swinger, what actually ends up happening is as the pitman arm moves, it'll be changing height in the chassis, and that'll actually start fucking with the ratio you have for the turning tightness, so to speak, relative to the ratio in the box and the pitman arm length. That's just, it adds another variable to the equation. If this guy right here is, let's say I put him parallel to the ground, and this is at 4 degrees of rake, so he's now at 4 degrees, so that pitman arm is now kicked at 4 degrees relative to my swinger. So as the pitman arm moves in the chassis, the height of that changes, and that ever so slightly changes the ratio. In other words, it will speed up and slow down the steering quickness. So you have to factor that into the equation. So your steering quickness is going to be a factor, or at least how I like to design these, is a factor of the pitman arm relative to the gear set in the steering box when you make sure that the steering box is perpendicular to your swinger. If the steering box is not perpendicular to the swinger, you just added a third variable into the equation for quackulating steering quickness. So I like to keep them perpendicular. Simplify the complex. Parallel swinger, yeah, again, I went through that. I hammered through that. Vertical versus horizontal swingers. Okay, so the main thing here is horizontal swingers suck balls. You're basically introducing a fuckload of inconsistent Ackerman. I mean, you can dial the Ackerman appropriately with that, but if it's horizontal in the chassis as opposed to swinging vertical in the chassis, it just creates a whole nother headache of issues with the Ackerman mitigation stuff. So any of these trucks that you see, typically speaking, a modern competitive trophy truck that's running swingers, it's all going to be vertical swingers. So if you can, the preference is vertical swingers. If you can't avoid it, horizontal swingers can work, but typically speaking, they start to fuck with other characteristics way more. And so now you get into another whole battle of another thing that you're fighting with Ackerman and through turn bump steer and shit like that, because the horizontal swinger drastically changes the depth in the chassis of that interior steering point relative to the upright. And that's, again, anytime you can control that stuff, obviously the less of a headache, the better your day is going to be. Various steering box options, Rams. Okay, so for me, Power Steering Solutions. This one that's pictured right here is a Power Steering Solutions billet box. I have reviewed that in others. That's my personal favorite. But that does, and then this ID truck that I showed, all-wheel drive swinger. This is a more traditional Saginaw box with a long sector shaft. This is the long sector shaft deal. So these are rebuilt to be more robust, and to be fair, a lot of trucks have run these without complications for many years. It's just that new one from Charlie, that PSS one, it's just more robust. It's a little bit more refined, and it runs better internals. So for obvious reasons, the guys now are switching over to that. And he's the only one I know of that's making it, and that's Power Steering Solutions. This is probably like a Howe setup, would be my guess. This might be one from Charlie. But this ID truck is older, so when Dave built this truck and designed this truck, there was no Power Steering Solutions box, long sector shaft box available. So just so you know, that's it. And then as far as Rams go, Howe does make long sector shaft stuff too, I believe. You could totally call them. The Rams are there to provide the power, so to speak. So just like a rack has the ram built in, like on the top of the rack, you'll see the ram move back and forth. In a steering swinger system, the ram is external, so to speak. So the ram is this top section in a steering rack. In a steering swinger, it is outside of it. So here is our ram. This is the ID Designs ram. I do believe he makes the nicest rams. So we obviously set customers up with that first and foremost, although Howe does make a nice ram too. On this setup, the ram is up above for packaging constraints. And I did this for a reason. So in the all-wheel drive trucks, you do lose approach angle and approach clearance because you are shoving a lot of this shit forward, so to speak, relative to like a rear-wheel drive truck. So in an effort to get us a little bit more or maximize that, we not only stuff the steering down in this corner, which helps me with my preference on the Ackerman stuff, but I also shove the ram up top. So the leverage ratio to him does match our throw. It does make this swinger a little gnarly, and it kind of looks heavy. It's really not. It was like only like we had it down to like pounds of weight. I don't have a picture, but we had that. We FEA'd that thing, etc. I don't remember if I put any of those photos in here, but whatever. The point being is that's all 70-75 aluminum. But the ram is what provides the oomph, so to speak, for this swinger system. So the box itself is not taking the oomph. The box is simply providing the direction, and the ram is providing the force. In this setup, you can barely see it, but the ram is tucked behind here and bolts right there. And this is, again, ID's setup. In this one, you can see this is a Mason. The ram is just right in front. And so this is an all-wheel drive as well. And this is kind of what I was referring to is on the all-wheel drives, this whole chunk of the chassis, the lower arm pivot, they kind of have to come up forward here. And so in that one that I was just showing you, I tried to mitigate and get more clearance up here for our client by optimizing some of this stuff, throwing the ram back there, moving him over, getting this center link into that pocket below the diff, moving that lower arm over in that area. So just different strokes for different folks. Mason has done a great job. They are doing fucking fantastic right now. Let's see at the 500. Well, they just keep showing in-car Brandon Walsh. So, whatever. But so yeah, so this is what I did on that one to help get some more of that clearance, and that's why I put that ram up in that location on this specific all-wheel drive. Okay, so I feel like we have done a good job of covering steering. Not bad. 2 fucking hours in. God damn it. And I still want to do shocks and vertical and horizontal bearing setups and arms. Well, let's go for broke. Okay, so I ended up rambling on for a long time into the shock and other stuff. So we're going to go ahead and cap this episode on the steering stuff because it was already over 2 hours, and I don't want this to get too crazy. So volume 3 of the IFS bulkhead stuff is the steering stuff. And then so volume 4, we're going to pick back up into shock and bump layouts, vertical, horizontal bearing setups, and a few other caveats. So that was that abrupt stop because I was just fucking going on, and this was going to be into like 4 hours. And I think that's a little excessive for each volume, so to speak. So that is a good rundown of both rack and swinger steering stuff. And if you guys have questions or concerns, shoot me an email. Again, there's a lot of stuff that is opinionated per se, or my thoughts, so it doesn't necessarily mean that what your buddy did or what you're doing is incorrect. It doesn't necessarily mean I'm incorrect. It's just different strokes for different folks, and a lot of cool stuff that we can manipulate in steering, and a lot of cool things that you can do with these trucks to cater to your client's specifications when it comes to designing these bits. But yeah, so this has been another episode brought to you by DIY flapper discs. Let's throw that back up there so I can justify this stuff again with the wife. Where were we? Stage buggy stuff. We're gonna go back. There's fabrication hard parts. There we go. DIY abrasives. So volume 3 of the of the JEHC IFS Design is brought to you exclusively by DIY abrasives. The only thing I sand stuff with. So yeah, thank you guys for checking this out. As always, admonish me in the comments. Make sure you dislike. The communists at YouTube do not deserve any of your fucking likes. And if you want to email me shit talk directly, feel free. info@DIYoffroad.com or jason@TekkConsulting.com. And as always, gentlemen, pitter patter.